Hello, this is Reed with EE201 Introduction to Digital Engineering. I am presenting my final term project, which is a simple audio driver. For this, my idea for the circuit would be to monitor a room and determine who entered the room based on some sort of input, either RFI tags or something of that nature. To have the circuit correctly distinguish who that person is to start the sequence in the system that would play that person's individual song as they entered the room. Now, if someone else were to enter in the room, it should stop the circuit as well as if they leave or if the door shuts. And as long as they're in there and the door is open, the circuit would play the individual song and then repeat it as long as those conditions are met. For this, I generated a truth table, K-map, and then the relays, or well, not relays, but the change of state diagrams for the flip-flops for each individual one, since it's almost two circuits combined into one at this point, depending on the output of a combination of who has entered into the room and who has not. That is why there's two distinct outputs, A and B, for whoever has entered into the room. After I came up with that, I generated a circuit using multisim. The top left corner, as you can see, is the comparator circuit portion. So it monitors the door and each individual person and then places them through a comparator. That way only one is selected. If it goes outside of the combination, like if two people enter and the door is not open, or you have those would all get blocked due to the logic of that circuit. Those in turn go on to drive the flip-flops, two individual flip-flops, and it also starts a counting circuit as well. That counting circuit counts down, and if you can look at the bottom right of that, there is a 3-input AND gate that goes back to the exclusive OR gates, which essentially resets the circuit once it gets to a specific timer. I chose 7 on this. You could choose anywhere between 0 and 9, along with adjusting the frequency of the circuit to lengthen or shorten that as much as you want. Additionally, just to make sure that the inputs and outputs are true, I ANDed the output along with the input plus what is being outputted from the flip-flops so that only true signals will make it through the circuit. From there, I reconfigured it just using chips so I could have a wiring diagram in order to construct my final circuit. On the breadboards, you see it gets kind of bulky, but I have all the IC chips, and it essentially ran out of space, so I had to jump around to another breadboard to continue on the circuit. To monitor the outputs, on there is two LEDs, a red and a green, one for person A and one for person B. And as the LEDs light up, that indicates that that would drive the rest of the circuit for the audio output. Different problems and ideas that I had with this. One of the problems, something that was necessarily desirable for the circuit, I would have liked to have the circuit be able to stop after a time frame instead of resetting. I don't think that's possible with the 47LS90 since it's asynchronous. It'll just keep continuing to count down. I tried different ways of stopping the circuit, both with logic and like trying to add out the input or subtract out the inputs, which quasi worked, except that since it was still on that type of counter, it would just reset as well as long as there was an input present, so it just continued to reset the circuit. Another thing that I found out was that it gets large and bulky the more and more that you add on to this. Some of the things that I would like to do in the future if I get a chance is to redesign the circuit with another sort of counter, maybe a 555 chip, that would allow it to actually stop once I hit a predetermined countdown. Other things that I would like to do, or that would probably be better, instead of just hardwiring it, probably run it as software instead of just a hardwire. That would allow it to start and stop as we desire, or anyone would want. Plus, it would allow for multiple inputs. Right now, you're just limited on the amount of inputs that you have onto the breadboard and for the circuits. List of references for all the IC chips that we used in this. As you can see, there's a number of them. Overall, it was a lot of fun to experiment with and come up with the ideas and make it work. Sometimes it was frustrating. Wiring up with this many chips was a lot of nitpicky because you are running so many wires connected to each other. So that was challenging, but overall, I think it was a lot of fun. Thank you for watching my presentation. I hope you have a great day.